All these presentations too, I think it may have been said already, are going to get put onto the PRC probably within a week or so. So this will be up there as well. I'm going to just go through some basic things about fiber optic cables, connectors, talk about inspect before you connect, IBYC, which was is a marketing thing that came over from Westover. Talk about cleaning. We've got all kinds of stuff here, so it'll be a little bit of show and tell and a chance to play with some of these things. Testing, which is focusing on the pocket class meters. Really won't get into the OTDRs here in this session. And then go through the products. I do have spreadsheet to hand out with the products, their pricing, what's in the kits. I think that some of the discussion that we just had is that not all distributors will be carrying all of these kits, but I think it is safe to say that everybody in this room will be repping these products into distributors in one fashion or another. Okay. I also have some other things that I'll probably hand out as I go. Fiber optic cable has been around for quite some time, since the 70s. Sends light down a piece of glass essentially from a transmitter to a receiver. There are really two basic types of fiber optic cable, which often people think are orange and yellow, but there's a difference between these. What's the difference between orange and yellow? I saw that there's probably about half the people in here have some fiber optic experience. Yes, okay, so single mode fiber, multi-mode fiber. Typically you've got the orange for the multi-mode, the yellow for the single mode. The slide that's up there shows you the difference between them, and the biggest difference is the diameter of the core. So the multi-mode fiber has got a much larger core size than the single mode fiber does. So multi-mode fiber in an enterprise space, this is what you're going to see, right? Multi-mode fiber does not get installed in the outside plant world. It doesn't carry the same data rates, the same distance. So if you want to go high data rates, talking about 10 gigabit per second, things like that, over long distances, you're going to have to go with single mode fiber. So multi-mode fiber, there used to be two different types stepped index, but we don't deal with that anymore. The wavelengths that multi-mode works at is typically 850 or 1300 nanometers. Goes short distances, commonly used local area networks, and things like that. There are two different sizes of cores, 50 or 62.5, and I think the previous slide showed that, okay, on the left side, 50 or 62.5. Single mode fiber gets into much higher data rates. People start talking about DWDM, carrying 40 gigabits per second, multiple wavelengths. You're talking single mode fiber. Single beam of light goes down the fiber, whereas in the multi-mode you got all these multiple beams of light, and it disperses your pulses, which is what restricts you. So single mode, you do see this in the local area network, but you predominantly see it in cable, telco, outside plant, and you see that the wavelengths that it works at are different, higher. 1260, 1660 are roughly the ranges. 1310, 1550 are the common ones that you have. It's got a 9 micron core, so it's an extremely small core fiber where your light is going through. Okay, fiber to the whatever is covered in there, and also CATV. I put this slide in, there really wasn't a great place to put it, so I kind of put it up front, because when we start to talk about measuring optical signals, we have these two terms, dBm and dB, and there's sometimes a confusion between dBm and dB. And on the meters themselves, on the pocket class meters, pushing a button will change you from measuring in dBm or dB. The big thing that you have to realize here is that dBm is an absolute measurement and dB is a relative measurement. So when anybody says dBm, they're talking about a very specific value. So 1 milliwatt is 0 dBm, so it's a power measurement. Anytime you see dBm, you're talking a power measurement. It's extremely specific. dB is a relative measurement. So the diagram that's there on the left kind of shows you that you're transmitting out at 0 dBm, an absolute value. You're receiving at the receiver at minus 8 dBm, which again is an absolute value. But your measurement, your loss measurement, is not 8 dBm of loss, it's 8 dB of loss, because it's a relative measurement. Okay, so when people talk about doing insertion loss testing, they're doing a dB loss measurement. They may measure dBm, but what you want to get to is your dB loss. Okay, And that's very critical to kind of understand when you start to be doing these measurements. There's big fancy formulas there. Just ignore them, okay? I don't get into the math too much, all right? You do see within this, what are some of the things that are going to cause you loss? The fiber optic cable itself will have a certain amount of loss to it, expressed in dB per kilometer or per mile. All your connections that you have will have loss, and again, fiber optic cable will have loss. Questions?
Copper cable, there's no measurement, and are they?
Oh no, it's the same thing. If somebody says dBm for a copper cable, they're talking the same thing. It's just it's a 1 milliwatt of electrical power as opposed to optical power, but it's the exact same thing, right? RF, you see this everywhere, right? And it's not always dBm. You can see other things after dB, right? I probably don't remember it right now, but in the cable TV industry, they do dBmV or something like that. So there's all kinds of things that you can do dB. If anybody DS1, there's dB DSX. So anytime that you see something after a dB, you're getting into a very specific value. And in this case, because it's an M, it's milliwatts, and that's our reference.